Okay, to get the minimum sample size, we really need to first find the critical cutoff value, and that's going to depend on whatever percent we have here. So we know we need to go 1 minus the percent, which would give us 100% minus 99%. That gives us 1%, or 0.01. That would be the area in both tails. When we split that in half, we're going to get 0.005. And that's what we then need to look up on our table. So again, it's that confidence interval percent subtracted from 100%, or the decimal version subtracted from 1, and then divided into to account for the two tails. Here we would then go negative infinity, negative z. We need to get 0.005, which is about right there, negative 2.57. So it's negative 2.57 and then positive 2.57 on the right side. So that positive 2.57. So we know that 2.57 times the standard deviation divided by square root of sample size will give us 0.06. Let me set that up here real quick. Okay, a bit like chicken scratch, but there's the equation that we have now. Again, that's the one that's coming from that table A, that critical value. And we need to solve for n, the sample size, keeping in mind it is in the square root. So if we take 2.57 times 1.1, we would get 0.06 equals 2.827 divided by square root of n. Essentially what we do then, we divide both sides by 0.06 and multiply both sides by the square root of n. And so that gives us that the square root of n equals 47.116. If we square both sides then, we get this 2,220 as the sample size. 2,220. I'll put that in there. And we will submit that answer, and that should work.